All right, so 8.4a, we are going to simplify and multiply rational expressions. What are rational expressions? Oh yeah, no, sorry. I mentioned this on Friday, but you may or may not have heard. We're skipping 8.2 and 8.3. Whole bunch of graphing stuff that we're not going to do. So 8.2 and 8.3 go adios. We're moving on to 8.4. Tomorrow we will divide, but for today we're going to do a lot of multiplication. And then rational expressions, think if something is a rational number, it can be written as a fraction, right? So simplify and multiply rational expressions. We're going to start with the simplify idea, and we're going to start on very simple simplifying just to get you in the right mindset first. Another way you can think of this is we're just going to be reducing a lot, okay? So for instance, this is as simple as it gets. 3/6. If I said simplify, you would tell me what? 1/2, right? 1/2. Divide both by 3, and we would get 1/2, okay? That's essentially what you're doing today, but with variables and rational expressions and lots of other things involved. But you are simplifying. You're making an answer as simple as you can make it. You need to, in other words, get common factors today with what we're doing, okay? Get common factors for every single one of these problems. So for this first one, this is just a little bit of review, just to get your brain back in this mode. If I gave you this, 27x to the third y, oh, you know what, negative 27, sorry, divided by 9x to the fourth y. Do you remember what to do with that? What do you do with the numbers? Divide them. Negative 27 divided by 9 is negative 3. Okay, what do you do with this? You subtract. So you can go 3 minus 4 is a negative 1, so x to the negative first on top would put x on bottom. My brain doesn't even go that route anymore. When I see them, I just think which one's bigger, put the answer with the bigger one, right? So the x is going to be on bottom. And then what do you do with the y's? They reduce to 1, right? Y divided by y is 1. So your answer would be negative 3 over x. Okay? How about this one? If I give you 2x minus 6 over 3x minus 9, do you remember what you need to do first here? You need to take out a common factor, right? So what would you take out on top? 2. So this would be 2 times x minus 3. And on bottom, take out a 3, and you'd be left with x minus 3, okay? Here's where you can reduce. X minus 3 divided by x minus 3 is what? 1, right? So we just slash those out. They're gone. They equal 1. So our answer here is 2/3. Okay? So we're going to be doing a lot of that concept today. Here are the steps you should be taking on all of these problems. So first step, when you are going to be doing this stuff, you are going to factor out the GCF, if possible. Okay, you won't always be able to factor out a greatest common factor, but if you can, you need to. Okay, so that's step 1. Step 2 is you're going to look for special cases. Typically, it's going to be the difference of squares. So I'm just going to write it that way. Look for the difference of squares. Do you remember what difference of squares looked like? Right, so if I had x squared minus 49, for instance, that would be what? Right, so remember 1 is plus, 1 is minus, and you take the square root of both of them. So x plus 7 times x minus 7, that's the difference of two squares. X squared is a perfect square, 49 is a perfect square. Okay, difference meaning subtraction. So look for these. They show up fairly often in what you're going to do. And then once we've done that, step 3 from there is you're going to factor. You're going to do the star method. Okay. All right. Let's take a crack at it. If I have 3x plus 6 over x squared plus 6x plus 8. So the first thing we said was we want to factor out the GCF if there is one. Is there a greatest common factor for either of these? There is on top, right? If we factor out a 2, this would be a 3. We would get x plus 2. On bottom, is there a GCF? No. Is it the difference of squares? No. So we're going to do star method. Now, a chunk of you might not need star method. You don't have to do star method here. If you can see what this factors as, great. If you don't see it, go ahead and set up star method. Remember with star method, it's a times c on top, b on bottom, and your a's go here, okay? So what can you multiply to get 8, right? 8 times 1. What can you multiply to get 8 that you can add to get 6? 4 and 2, okay? So the way we write it is x plus 4 times x plus 2. Okay? So now here's the thing. When we get to this point, now you can start slashing things away that are going to give us 1, right? So x plus 2 divided by x plus 2 gives us 1. That goes away. That means my answer is 3 over x plus 4. Questions on that? All right, next one. This one you have x squared minus 10x plus 25, and x squared minus x minus 20. Here's a special case actually that I didn't put up there, but you can look for any special cases, and if you know the shortcut, great. I feel like most people don't take the time to memorize the shortcuts, so you just factor them. But if you remember the shortcut on this top one, you're welcome to use the shortcut, okay? Is there a GCF for either one of these? Yes. No. Nothing you can factor out of it before you factor completely. Okay, so on top, if you want to do star method, you have what can you multiply to get 25 that you can add to get negative 10? Negative 5 and negative 5, okay? Which the shortcut is when this is a perfect square and this is 2 times a times b, that's when you can do the shortcut and just say square them both. I wouldn't for this because you're probably going to end up canceling one out. So I would still write it as x minus 5 times x minus 5. Technically, it is x minus 5 squared, but you'll see in a minute why we don't really want to do that here. So let's factor this one. What can you multiply to get negative 20 that you can add to get negative 1? It would be 4 and negative 5, right? So this is going to be x plus 4 and x minus 5. Be careful here, because I feel like at this point, people sometimes go, oh, well, there's an x over an x, so I can cancel out those x's. You can't cancel out x. You have to cancel out a factor, right? Something you're multiplying by something else. So we can cancel out x minus 5 and x minus 5, but then it has to say x, not plus, sorry. It has to say x minus 5 over x plus 4. You cannot do anything with those x's. Don't get rid of them. It's not negative 5 over 4. We're adding, okay? So you cannot cancel those out. So your answer would just be that, x minus 5 over x plus 4. Questions on that? Okay. Example 5. 8. 8. Example 5 looks like this. X squared minus 16 over 2x squared plus 6x minus 8. So it's got a lot going on. Notice on top, that is what? Difference of squares. So we can say x plus 4 times x minus 4. What do you got to do on bottom? You got to factor out the GCF first. So it's going to be 2 times x squared plus 3x minus 4. So if you do star method here, what can you multiply to get negative 4 that you can add to get 3? And what do you get there? 4 and negative 1. So this would be x plus 4 and x minus 1. Where do you have to be careful on this one? The 2. Don't forget about that 2. You factored out a 2 at the beginning, so make sure you put that 2 in there. And now you can start slashing. So we're going to take away x plus 4 over x plus 4. And then your answer would be x minus 4 over 2 times x minus 1. Now, you don't have to distribute. You could if you want. If you want to distribute it back in, that's fine, but you definitely don't need to. You can leave it just like that. Any questions? Okay, so we're going to start multiplying. Here we go. When you multiply, you have to make sure that you state any restrictions. And we put right on your quiz for you a spot like x does not equal blank so that you don't forget to do the restrictions. But make sure you get in the habit on the homework of doing that. And you need to do this before you start slashing. Okay, you can't just do it with your final answer because then you're going to be missing something, typically. Okay, so here's what you do. Example 6. Let's say we have 5x over 5x plus 5 times 10x plus 10 over 10. What I would do if I were you is I would think of them as 2 separate rational expressions. Do what we did before, so factor out what we can factor out, and then we can multiply at the end, okay? So if you look at this setup, on top, there's nothing you can factor out of 5x. On bottom, you can factor out a 5. So we're going to factor out a 5, and we're left with x plus 1. Okay? Now go up top over here. What can you factor out up top? A 10. So factor out a 10, and you're left with x plus 1. And then on bottom, we still have the 10. Okay? When you get to this point, don't start slashing. You have to set restrictions. What restrictions do you have here? X cannot equal negative 1, right? If I plug in a negative 1, I'm going to get a 0 in my denominator, which is not allowed. So x cannot equal negative 1. Make sure you do that before you start reducing. So now from here, when we're multiplying this, these are all, you can kind of think of this as one big bar now, okay? Which means x plus 1 divided by x plus 1, that's 1. 5 divided by 5 is 1. 10 divided by 10 is 1. What are you left with? X. So your answer is x, where x does not equal negative 1. Does that make sense? Yes, Mrs. Verhoeven, I totally get that. Awesome. So glad to hear it. All right, how about this one? X squared minus 4, God bless you, over x squared plus 6x plus 9 times x squared minus 9 over x squared plus 4x plus 4. What is x squared minus 4 going to be? X plus 2, x minus 2. That's a difference of squares. So x plus 2 times x minus 2. On bottom, how does x squared plus 6x plus 9 factor? And if you want to set it up in star method, go for it. If you can do it in your head, x plus 3 and x plus 3, right? Okay, so that's your left side. On your right side, that's difference of squares, so that's going to be x plus 3 times x minus 3. A whole lot going on here, huh? And then how would you factor x squared? Right, x plus 2 times x plus 2. What can you multiply to get 4 that you can add to get 4? That's 2 and 2. Okay. What do you have to do right now? Restrictions. Okay, what can x not equal? It cannot be negative 3, right? If I plug in a negative 3, I would get 0. So it can't be negative 3. What else? And negative 2. Okay. So we know that x can't be negative 3 or negative 2. And now you can start slashing things away. So x plus 2 and x plus 2. X plus 3 and x plus 3. Do you see anything else we can slash? One's positive, one's negative, right? You can't just cancel them out because they have the same number and variable. It has to be the plus and minus have to match up too. So you end up with x minus 2 times x minus 3 on top over x plus 3 times x plus 2 on bottom. Okay, questions on that? Okay, last one you're going to try on your own. Example 8, and this is it. Whoa. You have x squared minus 5x plus 4 over x squared plus 3x minus 28 times x squared plus 2x minus 3 over x squared plus 10x plus 21. All right, give that a go, and then we'll go over it together in a minute. All right, let's see how this goes. First of all, how many restrictions did you have? How many numbers? Not 5, 3 of them. You should have 3 numbers that are restrictions. Okay, so let's break this down, see what we got. What'd you get on top on the left? What can you multiply to get 4 that you can add to get negative 1? Negative 5, sorry. X minus 4 times x minus 1. Okay, what'd you get below that? What can you multiply to get negative 28 that you can add to get 3? That would be x minus 4 and x plus 7. What'd you get up top? Plus 3 minus 1. X plus 3, x minus 1. And then what'd you get on bottom? What can you multiply to get 21 that you can add to get 10? 7 and 3. So x plus 3 times x plus 7. Okay. So at this point, this is where you should be setting up your restrictions. X can't be, what number here? 4 or negative 7 or negative 3. This one's a repeat, right? You don't need to write it a second time. We already did that. And now you can start slashing. So x minus 4, x minus 4, x plus 3, x plus 3. Notice what you're left with. It's x minus 1 times x minus 1, which you can write as x minus 1 squared. And then what about on bottom? X plus 7 squared. In the numerator, it's okay if you have a 0. You can't have a numerator and 0 in the denominator, right? Yeah. And it's not wrong if you write it x minus 1 times x minus 1 over x plus 7 times x plus 7. That's okay too. It's just a little cleaner to write it this way, but either one of those is fine. Any questions on that? All right. So feel